So right now we're on Trinket and we are going to be looking at a little bit of code I wrote, and basically this is just the code for a bouncy ball, and we're going to see that it's dropped, goes in a free fall, and it bounces a little bit. And so what each line means is that 4 describes the ball in terms of the shape, the color, the placement, and the size, and any one of these things can easily be changed. So in other words, you can make it bigger or you can make it start somewhere different. For instance, its radius is 2. We can make that smaller. We can make it 1.5, for instance. Line 5 just describes the floor. In other words, we want the floor to be a box, or in this case a rectangle, and we want this to be the vector position 0, 0, 0, and we want this to be the size. So it looks like a floor when we first start out, but it's really just a line. Line 7, this is the starting time. Line 8, this is the change in time, so that's D is change, so that's 0.01 seconds. Line 9, this is the initial position of the ball in meters. So we're starting at 18 meters above the floor. 10, this is the initial velocity. So it's at 10. Let's say we could make this lower or larger. We could do it, I don't know, let's do something crazy like 30. Let's make it larger. See what happens. It was going too fast for the frame to actually catch it, so it hit the imaginary wall of the code. So let's make it smaller. Let's say, I don't know, 22. Anyway, line 11 is the acceleration of the ball due to gravity. Well, the same thing happened. Anyway, we get the point. This is the acceleration of the ball due to gravity, and that's because we're dropping it from 18 meters high. So when we drop it, it goes into free fall. So this is acceleration due to gravity. These two lines, lines 13 and 14, these basically just say while the time is less than 10 seconds, we're showing a rate of 100 frames. So, or it's calculating 100 times per second. So for every second, it's calculating 100 times, and it's going to do this until it hits, below 10 seconds. Then line 16 states that if the Y position of the ball is less than the floor position, then this makes it bounce. And so if we don't have this, I think this one makes it fall through the floor if we don't have it. Let's check it out. Okay, no, it just doesn't work. Okay. Anyway, this is what makes it bounce. So it's saying that if the ball hits the floor without this, once the ball hits the floor, it's going to go back up. So it prevents it from falling through the floor, basically. Then line 18, this line makes it so that the velocity, once it's dropped, is equal to the negative y velocity. So when it bounces, it's going to bounce with the same velocity as it was dropped with. Line 20, this is the position update formula. Line 21, this is the velocity update formula. And line 22, this is the time update formula. And so, if we wanted to, we could go through and change several of these things. Let's go back. Let's make this velocity vector smaller. Let's say 5. Oops. Then let's make this a radius of 0.01. 0.75. Let's make this larger. Let's make this 1. Okay, let's see what happens when we change those things. So basically you can go through this code and you can change anything that you want. You can make the change in time be different. You can make it 001. You can go through and you can change anything that you want, and you can add other things. You can change the color, and you can make it do different things. You can make it, there's so many different ways that you can use Trinket, and this is one of them.